All right, so tonight I'm here at Milwaukee Community Sailing Center, and I'm doing a presentation on DIY sailing electronics. And this presentation, I'm going to re-record it for the YouTube channel. And if you're watching the YouTube channel right now and you find this interesting and you feel like you want to make a donation, I'll put a link up at the bottom to Milwaukee Community Sailing Center's donation page. Please make a donation. It's for a really good cause. So let's get into it. This is DIY Sailing Electronics, part 1 of a multi-part series. So a little bit about me. I was born in Manchester, England. I have a degree in engineering from the University of Salford and then an MBA from Manchester Business School. Currently, I work as a product director at a hydraulics company, Husco International. The key thing here is that I'm not a software engineer, I'm not a computer engineer, I'm a mechanical engineer, so I do have some mechanical aptitude, but I'm not a software or computer engineer. I started sailing dinghies in the UK in my teens, did a couple of charters, and in my 20s I was a keen mountaineer, but I returned to sailing in 2019, doing my 101, 103, 104, and my safety of life at sea. So about Après. So the boat is Après. It's basically a French word meaning after. The reason I chose that name was because of after work, after retirement, and also, you know, I'm a keen skier, and Après ski is a well-known thing. Après is a 1996 Hunter 336. All the electronics were from before the year 2000. Most of them were Raymarine auto helm style. The nav center, which was on board, was an old-fashioned. It was a cathode ray tube, as was the radar, and basically it didn't have local maps either. So with no viable chart plotter solution, and looking at a replacement cost in the year I bought the boat of $700 to $1,000, I was looking for other options. So I did some research and I came across Openplotter. So what is Openplotter? Openplotter is an open sourced operating system for a Raspberry Pi, which is a low-cost single-board computer. It incorporates commonly used marine software, a data handler called Signal K, which is a modern and open data format for marine use, a chart plotter. It uses OpenCPN, which is concise and robust chart plotter navigation software, and then dashboards for gauges, etc., and autopilot support. There's links here to the web pages, and I wanted to point out the instruction manual. Always go to that, Openplotter, read the docs.io/latest. Very important that you go there. It's very straightforward. I've written a couple of pages myself. So what does it run on? It runs on the Raspberry Pi 3, 4, or 5. The current model is the 5. This is basically of 2025. The Raspberry Pi Foundation is a UK-based charity with a mission to enable young people to realize their full potential through the power of computing and digital technologies. Basically, they wanted to put together a low-cost computer that anybody could hook up to any television and be able to use and program and do some cool stuff on. People have started to use the Raspberry Pi for many, many applications, from home automation to pretty much anything. There's lots of industrial uses for it as well, and it's a pretty robust platform. It is still a low-cost computer with prices from $35 to $75. It's powered by 5 volts, which is USB-C, and really you can get one of these up and running on a boat with a 12 volt to USB-C or 12 volt to 5 volt reducer. They include a 40-pin general purpose input and output set of pins, and that is what you see over here. And from these you can connect up a variety of different peripherals and different sensors and so on to make your Raspberry Pi really come to life on the boat and really give you some information. More information about the Raspberry Pi is available from raspberrypi.com. Also, there's a link here to Amazon. You can basically buy them from Amazon. Last year, I used the Raspberry Pi 4 Model B, 4 gigabyte, and this year I have a Raspberry Pi 5 4 gigabyte as well. So Openplotter also incorporates a data handler, and this data handler is known as Signal K. The Signal K flag means communication, and that's really what this data handler does. It allows everything within your system to work together and all the data to be pulled into one location, regardless of what medium it came in by. The data sources that I'm talking about are things like, from a marine point of view, it could be CTalk 1, it could be NMEA 0183, or it could be CAN based like NMEA 2000 or CTalk NG or DeviceNet. It could also be non-marine specific, things like Wi-Fi or Ethernet, things coming in by Bluetooth, things coming in by USB, so general USB serial connections, and then also by the general purpose inputs and outputs. That could be analog, it could be digital, or it could be I2C. It provides a remote data access point and remote monitoring. For instance, if I leave my boat instruments turned on, I can access them directly from here and see what's going on the boat. Openplotter also includes a chart plotter, and that chart plotter is OpenCPN. Now, OpenCPN is a chart plotter and navigational software program for use underway or as a planning tool. It was developed by a team of active sailors using real-world conditions for testing and refinement. It has route navigation, as you would expect, waypoint navigation, autopilot output, so you can control your autopilot directly from it. It has the ability to split screens, so you can look at the map in two different ways on two side-by-side screens as shown in the picture. It has AIS support, so you can see AIS targets and also DSC target. If somebody hits the panic button on the handset and transmits an SOS via their DSC VHF radio, then you'll see it on your screen. And I know that from experience because somebody did it in a race, and we were the first and only boat to react to that. Also, you can overlay wind data, so you can put grids over the top. It also has MOB, so in some races, for instance, it's required that you must be able to have an electronic way of recording a man overboard. And as you can see on the screen here, on this screenshot, this one here, you press that button and it will drop a man overboard position, so you can then use that as a guide as you go past it and then come back to it. Also, you can use GPX. You can import and export GPX, and there is basically a chart downloader software for North America. This is great because the charts are free and they're part of NOAA basically. And then elsewhere, there are ways to get charts, both via subscription model, or in some cases, you can bring your own maps down. From a dashboard point of view, I use something called Kit. It's basically a plugin for Signal K, and it allows you to show data on your screen. There are some examples here of particular ones that people have done, and you can show your wind information, including speed and angle, both apparent and true, and then also heading and course over ground. Historical data charts you can do, analog gauges, digital readouts, whatever you want really. You can also embed web pages. For instance, you could pick a particular sail flow point that you wanted to always have in your dashboards, and you could do that. You could basically have a weather dashboard. You can also include race timers and buttons for things like digital switching, also autopilot control. So how do I use it? Well, so I have two screens, one at the helm and one at the nav station. And these two screens show exactly the same thing. So when I'm at the helm, or my crew can see the same thing that I'm seeing at the nav station. So this is an active picture from the Queen's Cup, which is a race across Lake Michigan in 2024. You can see rain on the screen, so it rained pretty heavily all the way through. You can also see on the left-hand side, and this is how I have my system configured all the time. On the left-hand side, I have a map, and this is OpenCPN. So within that map, you can see a blue line which curves, and you can also see a red line. The way I've done it is the blue line is the wind prediction. So that is a wind prediction that I've created from QTVLM. And the red line is basically a straight line between the start and finish points. The green triangles you can see there are other boats. So there are 4 other boats around us at this point, and that's their AIS signatures that you can see. On the right hand side, you can see my dashboard, and the dashboard has a big wind gauge with all the true and apparent wind information on, but it also has my speed over ground, my speed through water, and then my velocity made good. So my velocity made good to the finish line. It also, if you look at the bottom right hand corner, you can see the average true wind speed for the last minute basically, and that's what that shows. Also, the angle to waypoint is telling us how far off course we are. So right now we're about 12 degrees off course, but at this point we were close hauled, and we were, as you can tell by the wind, we were close hauled, and we were pretty much holding the course as best we could. So it really didn't matter. So what does mine do? Well, this is a schematic of my system, and as you can see, it's pretty in depth. So starting with the Raspberry Pi here, you can see that I have this area here is my CTORC, my old CTORC gauges. So speed, wind, and depth all going in to the GPIO ports, and basically feeding information in. I also have a magnometer that does compass, pitch, roll, which is heel, connected in as well. And then I have an Ethernet connection, which is both Wi-Fi around the boat and also 4G out to the cell towers. Connected up, as I said earlier, I have a 10.1 inch touchscreen at the nav station, and I also have the 15.6 inch waterproof screen at the helm. There's a couple of powered hubs in here. There's a USB dongle. There is an AIS transponder that fits in here and connects into both the system via USB and also directly into the my VHF. And my VHF speaker out goes into the Raspberry Pi and then out to my stereo. So I can actually listen to the VHF through the boat stereo. Also, I've got some temperature sensors here, also connected directly to the Raspberry Pi. And then via Wi-Fi, I have these units, and these units are low-cost little computers in their own right. And basically, this one senses the engine, so it has things like oil pressure, and it has RPM, and it has various environmental sensors and temperature sensors, and it also has a bilge high water sensor. So if the bilge overflows, then that will basically tell me on one of the screens. It also has a battery monitor, so there's another battery monitor here, and the battery monitor gives me voltage, current, and state of charge for the 3 batteries that I have, and also gives me the level of my fuel with the fuel gauge, and also gives me the level of the black water tank as well. I also have a Renogy solar charge controller, which is connected in via Bluetooth into the system as well. And basically gives me how much solar current is there, and what the voltage is, and what if it's charging. I can also connect up things like laptops, tablets, my phone and my watch, and get information on those directly all around the boat. So how robust is it? So one of the things that always puts people off is how easy is this thing to set up, and I think a very basic system is really quite straightforward to set up. So the first thing we're going to do is we're going to search for Openplotter and then find the Openplotter website and navigate to the Openplotter website. Once we're on the Openplotter page, look over on the right hand side, find the section where it says download, and then download Raspberry OS images. Once you get to the images page, you'll see that there are a few options: Openplotter starting, Openplotter headless, and Openplotter touchscreen. Now all three of these versions are different versions, and you can use any you see fit. However, what I find is that starting basically starts the graphics card, and the Openplotter touchscreen gives you touchscreen access. And so I do that one because it's just basically a little easier. Download it, so press download, and then you'll see that it's going to take about 20 minutes to do. So while that's downloading, we're going to download and install Raspberry Pi Imager. So Google Raspberry Pi Imager and select the download of that. So we'll go to the Raspberry Pi website, and then we'll look for the imager to download for Windows in my case, but if you need to do it in Ubuntu or Mac, you can do that as well. That takes a lot less time. It takes a few seconds really. Once it's downloaded, install the tool. Go through the setup process, and it doesn't take very long to install on your computer, and then you can run the tool if you need to, but you've got some time. 15 to 20 minutes later, when the download has completed, what you're going to do here is open the location for that, and just make sure you know where it is. Then what we're going to do is write an image to the SD card. So take an SD card over 8 gigabytes, plug it into a USB, or if you've got one in your computer, plug that in as well. And then what we're going to do is make sure you're able to wipe this card, and then go to your Raspberry Pi Imager. You choose the device. Now this could be a Raspberry Pi 4 or 5. They are different from each other, so basically pick whichever one you want to make the card for. And then here, go to custom, use custom at the very bottom, and then now find the downloaded image that you downloaded and click on it. choose the storage, so you're choosing the SD card that you had, and then press next. We don't want to do any customization, so here press no, and then it will ask you if you're okay with blanking the device. Press yes, unless you're not, then get another card. So now it's writing, and this will take some time. A few minutes later, the writing will complete, and then it will verify. So it's going to take a few minutes as well to verify, and then that will be it. It'll be finished. Now it's basically going to ask you to remove the card from the reader, and then you are ready to go. So now you have your SD card. We can use that to plug into our Raspberry Pi. So now you've got your SD card and it's flashed with the Openplotter operating system. You basically just plug it into the Raspberry Pi, connect the Raspberry Pi to a screen, add a mouse and a keyboard to make it a little bit easier, and turn the system on. Okay, so this is the first boot up of an Openplotter image. I'll probably speed some of this up. Then it rebooted right there. And here we have it, Openplotter. So the first thing that Openplotter does is goes through the starting sequence where it checks for a variety of different things. Okay, so the first thing we want to do is go in here, and you'll see now you've got internet, sound and video, graphics, accessories, Openplotter, and preferences. First we go to preferences, and we're going to go to Raspberry Pi configuration. Now this is quite important. The first thing you should do is change the password. So the password is Raspberry, and the username is Pi, and you should change the password. So new password, I'm going to put Milwaukee Community Sailing Center rules. Pick any password you want, but just change it. What we're going to do as well while we're in here is we're going to change some interfaces, and we're going to basically turn on shush, and we're going to turn on VNC. So now we can remote in. You need to set up Wi-Fi. So we're going to click on here, and we're going to click to set the Wi-Fi country, and we are going to set that to the United States. Then once we've set that, we're going to go here, and we're going to find our network that we're going to connect to. So we're going to connect to this, and put your password in for your network, and then press connect. Now we're connected to the network. We can actually now remote in and record this on the screen directly. So now you've got your SD card and it's flashed with the Openplotter operating system. The first steps are covered in the Read the Docs document, and we will cover this page in more detail in the next episode. Okay, so how much did I spend? So let's start with the Raspberry Pi. The Raspberry Pi was about $60 for the version I have, which is, I have both the Raspberry Pi 4 4GB and the Raspberry Pi 5 4GB, and they were both about $60. Power supply was about $10. The compass was about $10. My router was about $70, and about $40 a month for the 4G connection. But you don't need that to get the system working as I have it. $20 per USB hub, where I've got two of those. $20 for a USB dongle. A GPS dongle. The AIS system was about $250. My monitor was a big part of that and was about $624. And then all of the one-wire sensors are about $10. They're really cheap. You can buy a pack of 10 for about $10. The 10-inch screen that I have at the nav station, it was $141, and then the device to get the C-Talk in was about $5. My engine monitor in total, including all the sensors, all the sensors and all the connectors that I've got in there, oil pressure sensor, environmental sensors, and the coupler, optocoupler here, were about $60, and about $70 for the battery monitor. But that monitors 3 different batteries as well as the Blackwater sensors. So my system individually wasn't very much, but all in all, it does add up. How much could you spend? Well, for a basic system at the helm, you'd want to start off with a Raspberry Pi 4 4GB for about $60, the power circuit that I was just talking about at $10, a waterproof box for it to go into. You could get a waterproof touch screen, a 7-inch waterproof touch screen for about $175 from the same manufacturer as I got mine, with a USB cable for the touchscreen and also an HDMI cable for about $5 each, for a total of $266. If you wanted to add things like NMEA 2000 adapter, you'd be looking at somewhere between $10 and $25, or an NMEA 0183 for about $18, C-Talk 1 for about $5, and then GPS from $12 to $20. So at this point in the presentation, we opened the floor to questions and discussion, and there was plenty of discussion about the whole system and how we use it and so on. So if you have any questions, ask them away in the comments, and I will answer them. So in the next episode, we'll do further setup of our new demo system. So we'll work more on the Raspberry Pi, we'll add a GPS unit to it, and we'll add a compass to it, and do that as an example of how to set up other equipment. We'll also go through issues we had to overcome. So power circuits and hot shutdowns can be an issue for the Raspberry Pi, and I'll go through how exactly to overcome those. Waterproof cable connections, and then things like the derived data plugin, which basically you can use to generate the time to go and steer error, so tacking angle and things like that. And if we got time, we'll look at independent projects, how to create an ESP32 NMEA 2000 battery monitor, and then I'll also talk briefly about my 5-inch data display that I'm working on. Thanks for watching. Please like, subscribe, and comment.